Good afternoon, everyone. Good afternoon, participants, to this session on CCAM and artificial intelligence. We are going to discuss how effectiveness and user acceptance are related to AI and CCAM. My name is Margriet van Schijndel, and I'm moderator of this session. Besides this, I'm Program Director Responsible Mobility at Eindhoven University. I'm Foresight Group Leader CAS, Connectivity, Automation and Safety at EARPA, an association of about 50 research organizations in road mobility. And as per the first General Assembly of the CCAM Partnership Association, I'm officially now also Cluster Leader for Cluster 5, which is Key Enabling Technologies, and that really includes AI. So I'm looking forward to the discussions that we are having this afternoon and see what we can discuss here. Well, the discussion of this session, the topic of this session is CCAM and AI. But in our preparations, I think we have seen that 1.5 hours is by far not long enough to discuss this, but we will give it a try and have a focus on this. What we've seen also in our preparations, but also within the CCAM partnership discussions, is that AI can have a huge potential to change in-vehicle decision-making processes, as well as new services, safety solutions, and AI can play an essential role in especially critical situations and in complex situations, and also in integrating vehicles into the overall mobility system. And we think that AI can bring incremental changes to CCAM, its development, its deployment, but provided it has a clear and proven effectiveness. Furthermore, user acceptance plays a critical role also in this. So in this session, we will discuss issues like AI can be used for situational awareness, for decision making, for triggering of actions, but how? What's needed to be done? How does AI move these topics beyond the current state of the art? What are the most eminent and urgent benefits that we are discussing about that we need? And do this, and maybe other technologies, inherently bring improvements to road safety? Or is it not that one-on-one, that effect? Should we strive for it? How should we do it then, if? How can we also ensure that people have trust in our technologies? And as we've learned from some of the previous sessions earlier today, trust is a must. I think that one of the keywords coming from this conference, which is buzzing around also on Twitter, if you haven't heard it yet, that's a good one. So how do we deal then with the fact that people have a higher tolerance for people failing in mobility choices or in mobility than technology in traffic situations? So quite a lot of things that we are going to discuss, and our panelists will give it a good go. I think I've seen their preparations for this. They will start with a brief introduction with their setting of the scene, and we have really different perspectives on this topic. We will discuss this, and after that we have about 25 minutes a panel discussion. We've prepared for that, but we hope that you will be using Slido as in other sessions also to bring in your questions to the scene so we can discuss them as well. By the way, our speakers have prepared some Slido questions for you too, to see also how do you feel about AI and CCAM, and how are the benefits or the risks or anything. So you have a couple of questions, so I hope you will be ready to answer some of those questions so we can take that on board in our discussion. Of course, normally we would ask you to raise your hand in the meeting room, but obviously we don't have sufficient screen space to see all raised hands. We use Slido for this. Well, and as a first start, I have 2 questions for the audience. So I think Slido will be opened within a couple of seconds. The 2 questions that we have prepared for you all is, what positive effects of increasing levels of AI in CCAM do you foresee? And it's an open question, and we will draft a word cloud on that. Just before we start the panel discussion, we'll have a look at it, and the speakers will reflect on what's actually your input. So first thing is coming in. Good. We do have a second survey also for you, which is not on the benefits, but on the risks. What risks do you see with increasing levels of AI and CCAM? So reflect on your answers in a later stage, use the time and feed in your inputs, please. Would be highly appreciated. So while you're doing that, we already go on. And our first speaker is Clara Otero Perez, who is a physicist from the University of Santiago de Compostela in Spain. She's Director of System Innovations for Automotive at NXP Semiconductors in Eindhoven. And within NXP, she has a long track record of working on automotive and secure connectivity related projects. And she's been department manager, driving innovation activities, both internal and with partners in the stakeholder fields, in direct and subsidy projects in the areas of, for instance, Internet of Things, connected cars, and cooperative mobility. And now, as Director Systems Innovations for Automotive, she is responsible for scouting new systems and applications where NXP products would play a role, and of course also build concepts, proof of concepts and demonstrators for those new applications, like applications in connected cooperative mobility and autonomous driving. So Clara, the floor is yours.
Thank you very much, Margriet.
Sorry, before you kick off, you have a question for the audience as well. And while you are speaking, I hope they had some further inspiration also on that question, because your question is, which word comes to your mind when you hear the sentence, AI will drive your car? And it's a nice challenge again. And once you finish your presentation, we look at the answer. So this one needs to be filled a bit faster than the other ones. But now, Clara, the floor is yours.
Indeed. Thank you, Margriet. Thank you for the introduction. Welcome, everybody. My name is indeed Clara Otero. I'm working for NXP, previously for Philips, with a long track record on innovation. And I'm trying to see my slides on the screen, if possible. Okay, well, let me start even without slides. I work for NXP Semiconductors. We are a semiconductor company, one of the largest worldwide. We are operating in more than 30 countries and have more than 30,000 employees. We make semiconductors for different markets, for automotive, for industrial and IoT, for mobile, and for communications and infrastructure. Almost half of it, a little bit less of the NXP is making electronics and for automotive, which is one of our larger markets. Actually, in automotive, we are one of the, if not #1 semiconductor provider. We make electronics from tire pressure monitoring to window lifters, but also radars, autonomous driving platforms, battery management, and of course, connectivity. So what is NXP vision about the future on this connectivity? We see one car with 3 different missions and technology evolutions. On the one side, we see the self-driving car. The self-driving car where it's going to be more conscious, it's going to learn from its environment, it's going to take decisions, it's going to have ultra super sensing and processing, and it's going to connect to the infrastructure. We also see the convenient service-oriented car that is adapting to your needs. It's able to bring your personalized and your touch to the in-car experience. And finally, we have the sustainable vehicle that is basically looking at the transport at top efficiency, looking at new infrastructures and also new battery technologies. All of that, so all of these 3 different cars are supported by what we call the technology vectors. It is about sensing, everything becomes more aware. It's about thinking, everything becomes smarter. It's about acting, being very efficient. And all of that connecting to its environment, connecting to the infrastructure, which means that the car is not only dependent on itself and its environment, but is also getting advantages of being connected to the larger picture. So now I see my slide. We can go maybe to slide number 5, which will be the next one in my story. In slide number 5, we see that very important in automotive, you mentioned it, trust is a must. For us, in semiconductors for the automotive market, safety and security is what conforms this trust. So in the next slide, you can see the triangle. So what we look at? We look at functional safety, we look at security, and of course we look at reliability and robustness. And these three pillars are a must for everything that we do in automotive. So what about the AI? How is AI boosting our connected and cooperative automated mobility? In the next slide, you can see all the different aspects that play a role in the car. So AI is already there. We already have a lot of AI, a lot of machine learning embedded in our cars. And we see that role growing and growing. It's growing, for example, if we take the driver replacement, we see that we started with some very simple advanced driver assist kind of features. And we have now more and more helpers in the car. Is able to warn it when we are moving away from the lane, is able to warn us when we are getting too close to the car in front of us. So all of these sensors and all of this information is helping us, is helping our car to drive better. Also the motor, being able to efficiently control the motor to save energy. All those topics are make it that at this moment we have a lot of machine learning already in the car. Especially when we talk about connectivity enabled services. So the cooperative and connected car is not anymore about a car by itself, but it's about the car linked to the other cars in the environment, and is looking at the big picture and see what is the best course of action here. And AI and machine learning is and will play a very important role here. Similar with security, with powertrain, with driver monitoring, knowing whether you're falling asleep behind the wheel. So all of these topics already have machine learning components, and that will keep on increasing. It will keep on helping our driving to become more secure, more efficient, and all in all, a better experience, a more enjoyable experience. So what is my message for today? If we go to the next slide. Yeah, this was the one I would talk about. So the next one, which is my final slide. This is the message I would like to leave you with. We see electronics and we see artificial intelligence coming, and it's not a question anymore whether is it going to come, but it's already there, and where is it going to stop? Because we do believe that there are more and more data being generated, and we do see that sometimes some mathematical, so machine learning algorithms are at calculating what is the best course of action than we as humans are. So machine learning is helping us to offer new services, to reduce casualties, to enable sustainability, and all of that while keeping us safe and secure. So my call for today will be, let's demystify AI and unlock its potential. It's not about machines taking over. It's about using these very advanced algorithms based on lots and lots and lots of data to help us move forward. And of course, data is key, and we have to make sure that we are providing the good and the right amount of data to avoid biases and to avoid wrong decisions. So let's look at the word cloud. If it's there on Slido. Oh no. Good. So indeed, a little bit of everything there. Cool, safety, future, responsibility, but you also have worry, oh no, unpredictability, scary, taxi. I think a bit of everything is there. Machine learning is a very powerful tool, and we have to make sure that we are using it for our future, for our safety, for our cool features, and that is not taking over as bringing us places where we don't want to be and giving us advice that we don't want to have, etc. Oh, science fiction, that's a nice one. Yeah, I think there was a trend a few years ago where basically it was about every car will drive by itself by 2030. Well, that's not going to happen under some very close conditions, etc., etc. But it's more about how do we get there? How do we make sure that we are taking the advantages and we are automating more and more and more? And one day in the future, it will happen.
Good. Well, thanks a lot, Clara. It's very nice to see that there are some links also to what you presented. And unfortunately, we couldn't see too long your very cool picture of the vehicle with a lot of applications with examples of machine learning and AI that you already are working on and have already developed. So that's a pity, but I think it was a very nice introduction also in setting this part of the scene. And it's good to see that your call for demystifying AI and CCAM is I guess supported also by people bringing in inputs to the Slido. So let's see if we can work on that in our discussion.
Thank you very much.
Thank you. Our next speaker is Patrick van der Smagt, who is Director of AI Research at Volkswagen Group, and he's leading the Machine Learning Research Lab of Volkswagen in Munich. The lab focuses on probabilistic deep learning for time series modeling, optical control, robotics, and quantum machine learning. Furthermore, I think you see it in his first slide as well, Patrick is also faculty member of the LMU Graduate School of Systematic Neurosciences, and he is research professor at, I don't know how to pronounce this, Patrick, you'll help me, Laurent.
I can't even do it myself, so go over it.
You have it on your screen, sorry.
Laurent University, as far as I know, but my Hungarian is bad.
Yeah, okay, but you've heard it more than I have. And furthermore, Patrick, you are also founding head of the European Initiative on Certification of Ethics in AI Applications, APTIV, and a member of the AI Council in the state of Bavaria. Well, having said that, I think, Patrick, you have also a challenge for the audience. They can think about that while you are speaking. The question is, do you trust that the big tech companies use machine learning for your better experience? Well, Patrick, I think the challenge is yours now to tell a story about that. And I think you have very nice and cool stuff to tell us.
Thank you so much. And I would indeed skip immediately to the next slide. And that's about what my lab is actually doing. So in all honesty, I know nothing about connected cars and automated driving and all of these things. That's not what my lab is working on. We're looking into fundamental research on control, probabilistic machine learning, and so on. And you see in the slides a few of our applications. We use it for music generation. We use it for stable tracking. We use it for navigation. We use it for control of highly dynamic systems, in this case drones, which learn to fly by themselves. All of those based on probabilistic neural networks that are trained unsupervisedly in time series model and so on. So it's a totally different approach to machine learning, or what people sometimes call AI, than you see across the board, because I want to go that step further. But it also means that we are really working on the kind of intelligence, right, in quotes, that we know from biological systems, or that we know from humans. And that means also that, yes, indeed, the regulatory part around that is at least as important. And I think that should be taken into the cradle. That means start looking at that from the very beginning. And my next slide shows you how we go about that. For that, next slide, please. I said it in the previous sentence. Thank you. I created an initiative. It's called APTIV, for Ethical and Trustworthy Artificial Machine Intelligence. You would see it in the next slide, but I can also tell you. This is an initiative which I founded with a total of 17 companies and universities. I'm not going to name them all here. But what we do is we don't create a framework of ethics in AI, but we operationalize that framework. Right? There are many frameworks, like the one from the high-level expert group on AI and of the UNESCO, of the OECD. And those frameworks contain very good rules and regulations or ideas on how to make AI human-centered and so on. but not how to operationalize that, how to use that. And that's what ATAMI does. So we take those regulations and we use that to create a set of application standards and how to do auditing of those standards. And you can skip the next slide, and if you ever get to that, and then go to the last slide. What we do in ATAMI is, first of all, we look into the ethical principles and requirements, as I said, starting off with the HLAC set of principles. We combine that with the AI processes and technologies for creating transparent or trustworthy artificial intelligence, and use that to create standards for those. The 17 companies, and since you're not going to be shown them, I'm going to mention a few of them. That includes ABB and Atos and Continental and Deutsche Bahn, Telekom, Zalando, Siemens, and the number of universities. We started end of 2021 to create our framework. Will be finished by the end of this year. After which we will make those public, our framework, in form of a handbook of best practices, of do's and don'ts, and of a standard and a certification part of that standard. And we will then also start applying those with our partner companies by the end of this year to create a more inclusive, a larger initiative than next year, which is then basically open for more partners, because we really want to do this for Europe, to extend the legal framework that was published yesterday, right? And the legal framework looks into high-risk applications, but ATAMI looks into the voluntary labeling part of that. And I'm very happy we could at least show my first slide. Thank you very much.
Thank you, Patrick. Yes, it's quite difficult because I know, and I've seen your slides, you have very interesting things to show, and it's too bad it isn't supported by the visual aids that you had prepared. So I'm sorry.
It happens. It's no problem.
Yeah. Well, let's hope that it doesn't happen while driving. One question I have, Patrick, maybe you can help me. Why is Volkswagen working on the fundamental research?
Well, it's a realization. I gave you some of the examples of the work we do, and those are very, very far away from what the applications that you know nowadays, right? The applications with respect to voice recognition, or with respect to video annotation or image recognition. Those are related to learning from really large sets of human annotated data sets, typically human annotated data sets. Even the autonomous driving, like the stuff that you see Waymo doing and other companies, are based on human annotated data sets. But we don't have good and stable methodologies and scaling methodologies yet, which work on non-annotated data and on control of systems, automated control of very complex systems. So there is fundamental research needed there with a long scope, and even a longer scope than you see in universities nowadays. And sadly, that kind of research is nowadays to a large part done by companies, right? And Google gives us a good example there. I say sadly because it's also it's a loss of the public ownership of that research. But let's look at the poll results. If big companies use machine learning for a better experience, a little, which is much less than yes, and I think little and no is stronger. So this confirms my personal feeling. I don't trust what the big tech companies, I work in one, but I don't trust what the big companies do with respect to my data, and I don't think that privacy is the biggest thing that they are looking at, because it's a business model, right? So I think regulatory, either regulatory along the lines of what the Commission published yesterday, but much beyond that, also in the non-risk applications, non-high-risk applications, I think is very necessary and helpful. Maybe not as far going as the GDPR, but certainly we should solve that problem.
Yes, thank you. I think that's one of the key topics that we I think should be working on these days. And thank you for showing it clearly. It's a bit sad that it's necessary, but maybe it's good. If we're not aware of this, we can't change it.
Well, better too soon than too late, right?
That's true. Good. Thank you, Patrick.
Thank you, Margriet.
Well, our next speaker is Nandita Mangal, and she's leading the vehicle experience platform of autonomous driving at APTIV. Nandita's work focuses on building in-vehicle experiences for automated driving assistance features. And you can hear as soon as she starts talking that she's very passionate about designing safe human-machine systems and frequently applying disciplines from cognitive science, human-machine interactions, and systems engineering in a joint approach. I think Nandita, she's focusing on building products geared towards future disruptive technologies. And I think, Nandita, you also have a question to the audience. Like, do you think that in-cabin machine learning applications will be able to meet the user needs of acceptance, trust, and privacy? And while the audience thinks about that, you give them further food for thought, right?
Yes, and thank you for the introduction. Yes, I work for APTIV, where a little bit about APTIV, we are a leader in ADAS technology, where we work with OEM partners to provide safe and scalable platforms. And as we continue to innovate on these platforms, there are a few things that I wanted to really bring forth on this few minutes of discussion that I have with the audience. The first is, and we've heard this word before, but trust. How do we make sure consumers trust our ADAS technology? And second is, how do we educate the consumers about what the ADAS technology does? And I see myself here representing APTIV, but also being passionate stakeholder in the community to ensure that we can ensure how we can see the future or explore the future ways we can continue to innovate, especially with machine learning and AI applied to the in-cabin sensing approach. So one thing that I wanted to touch on is trust, and it's a bit of a complex topic. We talk a lot about trust, but it's not a static binary thing if you think about how you use your car, right? You go through, as a new driver, say if you have a new car or a new ADAS technology, you go through phases, right? You first get introduced to the technology, you perhaps get into medium experience where you try to transition into a bit of a trusting more the technology, and then you perhaps become seasoned rider where you have seen the technology working in different situations, you've been exposed to different types of times, different types of journeys throughout your day of how the technology truly works. And you've had a very good mental model at this point of, say, how does this level of automation work? How does the lane departure warning work? And what is its actual scope? And what is it that you're actually very much responsible for? And the thing is that while we are having these two main pillars of making sure our platform is extremely safe, active safety focused, we also have a pillar of, well, how do we make the fact that it is something the users trust and not just turn off? The first time in that first experience, something didn't go right, and they're like, well, I'm just going to turn my lane departure warning off. And the way we like to look at that is it's a two-way street. So the car is trusting you and you're trusting the car. And in order for us to do that, we really think that we owe it on ourselves to really understand the human behavior. The machine, the vehicle really needs to understand a bit more about not just your state, if you're drowsy or distracted, but go a step further and really understand what are the behaviors you're doing in the car, and what's your emotional status and what's your cognitive load, and exactly what's your intention at any time. And the reason why we want to have this good picture of you as a driver is to make sure that we are really understanding what is it that your user task is and what's the context of your user task in the vehicle. And how do we use that information is actually very powerful for us, right? So we've already made strides with APTIV as an industry, with driver in-cabin sensing, with driver distraction management and attention management. But we've also, APTIV has worked with OEMs on driver modeling and applying machine learning applications in-cabin sensing. So the point here is that we really can use artificial intelligence to design these trust enablers. As a quick example, when we have a good model of the user, we're using multiple signals, multiple holistic way of contextualizing the task of the user. We can ask ourselves confident questions like, did you really intend to deactivate this L2+ system? Or was it an accidental deactivation of this automation and you're not prepared? And how can we help you? Or for example, you've seen this before, if you ask adaptive cruise control users, well, how did you get comfortable with using cruise control? We always see the answer, well, I took it on the road for 2 weeks and saw how it worked, right? So there's this learning phase with the technology. And that's where we feel it's really important to have this learning phase where we are modeling the driver, we're finding the times where what is the right time to educate you as you get familiar with this technology. Of course, when you're white-knuckled and staring intense in the vehicle due to certain traffic situation is not the right time to say more information about the technology. We want to make sure we are finding the right times where we can give you that information to help you on this journey of trusting the ADAS technology, to help you understand what this ADAS technology does for you, and also give you the right background of, say, any missteps or any false alarms that come up of how this helps you, right? So that's the premise of making sure we have these trust enablers and points in your journey where we can inform you better. And I think this is where AI really shines, right? Because we're taking this user experience, human-centered approach towards in-cabin sensing and trying to really understand, well, how do we holistically, temporally, and spatially make this model of the driver? If you're distracted, if you're perhaps examples of machine learning and in-cabin sensing are already there, for example, detecting microsleep before you actually get drowsy. So we're already there in machine learning. The next step is to model you as a driver so that we can help you gain trust in the technology. We can understand what is it that's helping you and what is it that's not helping you to understand this technology. And there's just so much input, right, coming into the cabin, right? We humans are such complex beings. We don't have just our eyes, we have emotions, we have a very sophisticated way of contextualizing the world with the road and the vehicle. And so we have a lot of sensor data coming in, and the idea is to holistically create this model and not be based on just a few static behaviors where you have a very rule-based approach, but there's lots of data coming in where we can actually have patterns to understand you and basically improve the road experience for you as a driver.
Okay, and that is the step that you would like to stress, that we need the contextualization of the AI in your
Exactly. Yes. So contextualization of what we are doing as a driver is and having the machine be contextually aware is actually a very important step, because humans, we are very adept at the context, and it's very difficult to impart that into a model, for example. So we need to have the road, the vehicle state, the automation level, the user's state, and also past interactions. There's history of the driver interactions with the ADAS system. So yes, there's a lot of contextual application here. We have to be context aware and also personalized to the driver and his behaviors in the vehicle.
Okay.
So yeah, I hope that this kind of shared some of my input on improving road safety and helping in cabin sensing.
Thanks a lot, Nandita. And let's see if the responses on Slido that, ooh, that's a bit challenging you, isn't it? It's not
No, I think, yeah. I think this is where we really need responsibility to make sure we are putting in the right checks, to make sure the user concerns are met in each part of model training and evaluation.
Okay, good. Thank you, Nandita. Thank you.
Thank you.
We go on to our next speaker, which is Grigori Parfjonov. He is from Tallinn, and Tallinn is leading the mobility track in AI for cities, which is an initiative focusing on using AI to make our cities more sustainable. In this initiative, there are 6 European cities and regions: Amsterdam, Copenhagen, Helsinki, the Paris region, Stavanger and Tallinn, who jointly are looking for AI solutions for mobility and energy to accelerate the carbon neutrality. The AI for Cities initiative challenges suppliers to come up with AI solutions that really reduce CO2 emissions in the mobility and energy field. And within this initiative, AI for Cities, Grigori Parfjonov represents the city of Tallinn, and he works here at the Department of Transport as mobility expert and has mainly been dealing so far with transport planning issues. While he starts speaking, he also has a challenge for you, which is if it would be you sitting in the car, would you rather trust it to make the driving decisions than doing it yourself? So, Grigori, the floor is yours.
Thank you very much. Apart from that, I'm currently working as well on developing the mathematical multimodal transport model that will allow us to give an overview what will happen and how will traffic flows change and how will decision making change for our residents. And if you could go to the next slide, please. I will give a quick overview of where Tallinn is in general. Is there the next slide? For those who do not know where Estonia is, because we are a relatively small country, it's right up north, just between Latvia and Finland. And basically over the past couple of years, we did get some experience of using autonomous vehicles at some point. Namely, in 2016, the government of Estonia started a work group to study all legal and operational aspects of autonomous driving. At the same time, since 2017, small couriers are legally allowed on the streets of Tallinn, and as well, more or less every year we hold autonomous vehicle tests. Last year, over 8 months, we have made almost 3,500 people driving an autonomous bus all over one of our city central parks. And yeah, that's where we are. We are piloting the stuff more or less. If you could go to the next slide, please. Basically, the idea of autonomous vehicles is not very new. I mean, the first prototypes were built almost in the 1920s, and with years, autonomous vehicles get more sophisticated over time. And over the past couple of decades, we can see that more startups, companies, and more companies in general are getting involved into the business. And if we look at the new cars we buy that are available on the market, we can say that there is a lot of new functions available. For example, driving assists, parking assists, and a lot of more functions with the word assist in the end of it. Makes you kind of think, is driving actually that hard? But nevertheless, you can Google a lot of road maps and you will get a lot of results at the end of the day. this particular one is the one I've had about 6 years ago when I was doing my master's dissertation in the UK, and it said then that by this time there would be something like 25% of connected vehicles, which I think we are a little bit behind schedule. Different question is, why are we behind schedule? So if you could put the next slide. Basically, there is quite a few challenges behind operating autonomous vehicles. Some of the areas of challenges you can see on the slide right now. Basically, there is quite a few social challenges. For example, can we actually trust and accept autonomous vehicles driving people around in the city without those having any driving license? Or, for example, the technological aspects, namely, what about digital infrastructure, or how will vehicles accept the infrastructure we have today? Because potentially it can happen that when we have autonomous vehicles on our streets, no infrastructure is actually needed because everything has been digitalized or in any other way. Also, will they fit with the overall political transport policy or not? And as well, there is a huge need for regulation and various highway codes. For example, even in Europe, some countries differs, for example, by the distance vehicles should overtake other obstacles and vehicles, or for example, cyclists. And I think it's a field where unified standardization should be built, because it would be relatively hard for one autonomous vehicle to upload a new set of regulations and operate it when it goes over the border. As well, economical aspects are in place. How will autonomous vehicles actually influence the all set up in industries, and will it actually take a lot of jobs away from the public? And what are the public benefits at the end of the day? This is a huge question which has been argued over years and years, and I'm pretty sure it will be argued in the future as well. How will it be driving on the streets? Should it be public transportation, or should it be personal vehicles? Or are we okay with empty cars driving on the streets while just avoiding simply getting parking tickets? I mean, this is kind of philosophical, I would say, but at the end of the day, what's the impact on the environment, and how should we deal with that? And it's mostly a field of discussion, really. Could you go to the next slide, please? So, because we do not really have much time to talk about it into more detail, I would sum it kind of up. I'd say that potentially very sophisticated autonomous vehicle systems, they are already available on the market. But unfortunately, it's relatively hard to start operating them on open streets due to various factors I've highlighted previously. On the other hand, if we talk about like the social acceptance aspect and theory of social acceptance, we can say that if something new appears, like for example, if a new way of decision making appears, such as machine learning, and gets in mass production towards the vehicles, we can say that it will probably require us to reset a lot of standards in terms of traffic management and so on and so on. So basically, I'd say there is a lot of things we should think about. And as well, traditionally car makers, they're trying to develop new vehicles and make them more attractive for people, considering the new functions. But I think if we are looking towards autonomous vehicles on the streets of our cities, probably this process should be led in configuration with all parties such as city authorities and, for example, communication companies, because obviously a lot of infrastructure will going to be related to communicating information from one autonomous vehicle to another. And I think that's it from my side.
Thank you, Grigori. Thank you. We still owe you the feedback of the audience to the poll we have for them. So it's just a small difference between the two groups. Is that what you did expect?
I would say at this moment probably yes, because even when we've been doing tests, people were kind of very cautious about driving an autonomous bus, which actually had an operator inside who could press the stop button in case something happens. But people were more or less cautious about it. I'd say that's probably the result I was waiting for.
Okay, well, I hope that in due course we can change it still. So let's hope for that. Thank you, Grigori. We go to our fifth and last speaker for now. This is Marieke Martens. She's full professor automated vehicles and human interaction in the faculty industrial design at Eindhoven University of Technology. And furthermore, Marieke is director of science at TNO Traffic and Transport. Marieke does have a background in cognitive psychology and human factors, and she is approaching automated driving from the behavioral point of view. And that means that her research does focus on the human inside the vehicle, the people around the vehicle that need to interact with it, and also on human factor issues regarding remote operators of the vehicles. Marieke also is part of the expert group on ethics for CAVs, connected automated vehicles, part of the ISO SC 39 working group 8 and 5, and part of the independent human factors IRETS group as well, linked to UNECE. So Marieke, you also had, I think, brought a challenge to the audience. You have 2 questions actually, so people can respond to those one-on-one. And they're quite long, and while we are running a bit out of time, I won't be reading them aloud, but you reflect on it once you finish your things. But we have 2 questions for the audience, and Marieke, you will challenge them further, I trust on that.
Yes, thank you very much, Margriet. I'm really happy in this session of AI that already some other speakers also mentioned this human perspective and the road safety perspective, because that will be primarily my focus of today as well. Next slide. Because what I always like is that almost every presentation, also I heard it during these days today, where people say, well, more than 90% of all accidents are caused by humans, so they fall asleep, people get distracted, and sensors do not, so there is a great promise in automated vehicles to bring safety to our roads. Next slide. But in order to really get this road safety, it also means that maybe we have to do more than just improve technology. And this is very often what I hear in sessions, is that as long as we improve the technology by itself, everything will be better. But as we also described in a paper, we show that bringing new technology aboard also means that we will get new sorts of human errors. So it also means that the original numbers I showed on the slide before will change. So we will get more vehicle errors. We will get more vehicle in interaction with the human errors, or more vehicle in interaction with the road errors. So these numbers will actually change. Next slide. So I really believe that we should not focus on technology alone, but we still need to talk about humans. So we need to talk about the person inside, who still needs to understand their vehicle and needs to know what to do in order, for instance, to take back control. We also need to focus on the people outside, so pedestrians and cyclists who need to interact with them, or manually driven cars who don't understand why a vehicle suddenly brakes or stops. And that all relates also to ethics that I will be talking about a little bit later. Next slide. So where traditionally the question used to be, how safe is this car? We're getting to a more complicated issue where we say, well, how safe is this specific car with these functionalities, with this driver in this specific context within the entire traffic safety system? So that really challenges us a little bit more. Next slide. So I wrote down some of the recommendations that I think are very important in order to bring in this human perspective, but also use AI in order to improve road safety. So the first one is that I really believe that automation should only be offered if it's reliable for a tremendous amount of time. So it means that indeed this car should have self-awareness and has to realize whether it can provide a reliable service or not. And by only offering it when it's reliable and not doing that when it's not reliable, we also get some more clarity for the person inside to understand who is driving. Is it the driver or is it the car? I think predictability is really important for a driver as well. So we really should demand predictable behavior for the person inside and the people interacting from the outside with these vehicles. And I believe that AI also offers, and this was also mentioned in this session before, possibilities, for instance, for driver state estimation and predicting, for instance, visual attention, but also estimating current trust levels. Do drivers overtrust or undertrust their car? And also be able to predict the time it will take for a driver, for instance, to be back in the loop. Next slide. I think intent prediction is something that is really important, and there's already a lot of important work being done in that field as well. And I think we should also demand that the system with the driver together drive safer. It was also mentioned in some of the questions to the audience that they should be safer than a manual driver alone. And I think it should also sometimes might need a mind switch from automating what is easy to automate towards maybe automating what's difficult and what's actually causing driver error. And lastly, I think it's really important, and this is maybe one of my main messages, to realize that just having loads of data doesn't mean that AI can actually learn human values or values behind human ethics. We get a lot of questions from developers as well who want to proceed and don't know how to do that. So my sixth recommendation is that I really believe that governmental bodies, so it could be the European Commission or, for instance, the Global Forum for Road Traffic Safety under UNECE, to actually define ethical goal functions to make AVs really optimize on road safety. Since they have been, these governmental bodies have been the guardian angels for road safety, also for manually driven cars. So I really believe that this would be a huge step forward. And I will leave it to that for now, so more for the discussion.
Good, thank you, Margriet. Well, we hopefully get a peek on the results of the first poll. Oh yeah, we have an agree, and I think you respond to that. Because I have a question to you, because you're not the first speaker today talking about user acceptance of CCAM, and you touched also on other things, but talking about this, do you think that we actually all have the same understanding of what is user acceptance?
No, because very often, well, on the one hand, it is, I mean, acceptance is not a binary thing. So it's not, I either accept anything to happen or I do not accept these cars on the road. So it really depends on what they do as well. And I think in that term, the term acceptance is not, I think, a right term, because literally when you look it up in the dictionary, it means to kind of do not care about any negative things that might happen to you. And of course, we don't want acceptance to be, we want AV embracement by the public, not just that they accept that they're there. So that's something else maybe. The thing is, so when you talk about trust, so I think acceptance and trust is also and seeing the positive outcomes are really related, but also trust is not binary. So you have dispositional trust. So how do people feel about what they've heard in the news and that sort of thing. Then you have trust about a specific situation. For instance, people who already have these functionalities in their car. Do you trust the car to take the curve? Do you trust the car to change lane in this situation? But then you also have learned trust, and learned trust changes. So the more good experience you have with these systems, of course, the more calibrated, I would like to call it, your trust is. So you want trust not to be too high. You don't want people to overrate the capabilities, but you also do not want under trust, where you don't dare to drive with the car, even though it's pretty capable of doing so.
Good. Thanks a lot, Marika. I think it's good to have that further perspective of what you are sketching and the user acceptance. I think you had a second question to the audience as well, and the answers are just coming in. Can you reflect on that? Is that what we expected?
Well, it's reflecting at least the way I feel, but because that's always one of the big questions that we had, and we also had that discussion in the ethics group for the European Commission. Who needs to define the way the car should be functioning? And of course, you can't literally define in this situation a car should always do that. That's not possible. So that's not something that I believe that governmental bodies should be doing. But in the end, deciding what is safe behavior in a more general context, I believe should be done by governmental bodies. So it's over 80%, I think, where people agree. So I'm really happy with that. But I also feel that I would be interesting, but maybe we can do that during the later discussions. If it's people developing these cars who actually rated that it should be developers that should be in charge. And also for the municipalities, we often have a very big discussion because they put these things on the road, but they don't have a lot of knowledge always about AI and automated vehicles. So can they really bear the responsibility of what these vehicles do?
Well, that's a question. I'm not sure if we would be able to answer that this afternoon, but it's one of the challenges that we of course have when thinking about connected, cooperative and automated mobility indeed. So thanks for putting the question there. I have a question to the panel members, and they know, and you can't see it yet, but I can see on my screen, yes, they start to get ready. But before we go to my first question, we asked the audience to give us some inputs on what they see as main challenges and main risks. So I hope we can see a word cloud on that, positive effects. Oh, so the panel is going to have a look at that and hopefully can respond to that in the answers on upcoming questions. So safety is one that hit the bottom a couple of times, and the risks, the explainability on the second one, you can see it has a central place and has been mentioned more than once. Less transparency, biases. So there are some issues that we have touched upon or need to touch upon in the next discussion. So thanks to the audience for giving this feedback. I'm not sure if you're still able to give any further inputs, but it will be relevant and interesting for us to see a final result there as well, also for the final report of the session. While having this picture from the audience inputs, I have a first question. While we are striving for the high user acceptance, responsible AI and ethics, they do play a significant role. But how can we ensure that these are integrated in the development process from the early stage onwards? Nandita, how do you see this?
Yeah, so I think we have to follow an approach where we frame the problem first instead of thinking about the data first or the AI model first. We have to really understand what is it the user needs are in this situation, and what is it that we need, what type of data sets we would need to accurately represent the kind of problem we're trying to solve. So for example, are we using real world data of drivers, or is it going to be in a simulator? Or are we using naturalistic driving studies to collect this data? And will that accurately represent, for example, say drowsiness or certain conditions of the driver that we're trying to solve for to determine his intent, for example? Basically, the way I see it is the data set needs to be iteratively reviewed as we go into the machine learning process by multidisciplinary teams, such as design researchers, scientists, in addition to the actual machine learning engineers, to review, have these checks in place to understand we haven't left big gaps in our data sets as we test our models, making sure it's correctly and accurately representing what we're trying to solve.
Okay, thank you. Thank you. And Marika, how do you see it from implementing user acceptance from an early stage on in the development process?
Well, I think the nice thing is that there's a lot more attention also in people like OEMs and all sorts of technical companies to actually understand that they should make something that is acceptable and safe to use and nice to use, and it feels comfortable. So I think it's really already a lot better than, let's say, 10 years ago. I also see it as a stepwise approach. So whereas the ultimate goal used to be to automate as much as possible, now we kind of realize that if we automate specific parts and make that feel comfortable and easy to use, then we can do the next step with that. So I really believe that not trying to automate everything, but just what feels predictable and comfortable and safe for people to use. I think that that's primarily important.
Okay. Well, thank you. Thank you.
Margriet, may I add one sentence?
Yeah, sure, Patrick.
All right, thank you.
Yeah.
Because it's an important question, and I think, in fact, the development process of these methodologies needs to be standardized, and that means that you need to know how to ensure that you get whatever responsible AI means, right? You have to make a definition of that. But those requirements must be part of the development process, and starting from research, but certainly in development and application. And that is in principle nothing new, right? I mean, it's an upgraded ISO 9001. It's not as simple as that. I'm now making a bit of a joke, but I think that's the direction one needs to go.
Good, thank you. I think it was slightly more than one sentence, but I'll gladly forgive you because it was.
The full stops were commas.
Or you make long sentences, maybe, I don't know. But thanks a lot. I think it's good to add that to the picture. Thank you. Thank you. We discussed at the beginning, and I think it was also shown a bit in Clara's slide, that AI can be used, for instance, for situational awareness, for decision making, for triggering of actions, especially in time-critical and safety-critical scenarios or applications. What do you think that are the biggest steps that we need to take at this stage, Clara, to make a big step forward?
Yes, so the issue, of course, of predictability and traceability and transparency of why a decision was taken or not is a very important one. We are not ourselves building the decision engines that are going to determine the course. We are mainly providing the hardware platform where those decisions are going to be implemented. So from our perspective, we do see very important to provide a hardware that is predictable and that is not failing, and that is safe and reliable. We do see that we are starting to use, for example, a dual computation. So you see in airplanes, there is always three completely different machines taking decisions and checking each other. Those have different hardware, different software. In an automotive, I think the economy will not allow it to really have this fully triple redundant system, so that you use completely three different independently developed hardware software algorithms that will tell you what to do. But we are seeing the trend towards establishing a clear boundary. So don't drive into a person, avoid that at all costs. Don't drive into the wall, and don't make such a stop that we will put the passengers in risk. And next to that, we have the AI versus more traditional. So we have been looking into a more, let's say, comfort, optimized decision-making that will take all the bells and whistles of your preferences, your style, your safety, your efficiency, while there's another one that might be a bit harder, a bit less complicated, but has all of these requirements in place. And those two systems will coexist and will make sure that the decisions that are being taken, they correspond in this set of allow the states to avoid mistakes. So indeed, it is making sure that the scenarios and the applications are being fulfilled. Here, the importance is as well, how good is your data, how good is the definition of the allowed states that are required. Of course, in NXP, we mainly look at AI on our physical systems. So you're looking at the motors, you're looking at battery management, and there you have very clear a battery cannot explode. So you have to make sure that this and this and these parameters are below certain thresholds. The same should happen when you talk about decisions that have to do with the humans and with the environment of the car.
Good, thank you, Clara. And I'm slowly progressing to see if anyone of the other panel members is willing to jump into this one as well. And now I have the challenge, because I have a very nice set of further questions to ask to you, but I think that the audience also has a full set of questions. We started a bit late, but we can't delay at the end of the session because there is a follow-up session as well. So I think we look at the question posed by the audience and see what we can discuss on that. I think there is a highly rated question from Susanna Kraak from the European Commission. What's your view on the recently published EU legal framework for AI and its risk-based approach? Does it provide a balance between boosting innovation and protecting human rights? That's a hint of an answer, but I'll give you the freedom to say, like the audience, yes or no, or how you can pick that up. Anyone willing to go first?
Happy to give my 2 cents on that. So first of all, yes, I think it does give that balance because of the risk-based approach. It's of course a bit early to say because it only came out yesterday. I mean, we've had a leaked version a bit longer, but not a full analysis. At the same time, the regulatory does not apply to vehicles, right? It is on high risk, but it seems to be excluding vehicles in the regulatory because of the fact that those are already highly regularized by other laws, and we can expect updates of that. But yes, I think the risk-based approach is the best you can do here. I think the high-risk approach is also quite a good one. It leaves the low-risk ones out of scope, but we have to work on that.
Good. I think some other panel members have seen it as well. I know you can't have evaluated it completely. I think, Patrick, you're quite honest there, and that's justified. Anyone else?
Yeah, I think it's also, it's very nice that's being mentioned. I think what's also important is that it's a topic that's been discussed for a long time, and we probably will be doing that for a long time. But I think now the time is really right to actually start doing it. So we can put everything in frameworks, but especially when we talk about AI, we have to start doing it and get experience with that, and then see, are these indeed the right things to do, and then maybe readjust. And as long as we do not do that, I sometimes fear that we will stay in only discussing for longer periods of time. So what I also hope is that based, for instance, on that document, we can actually also get along and say, okay, what does it mean, for instance, for automated vehicles if we start applying this, and does it really solve the puzzle?
Okay, well, thanks a lot. Thank you indeed. I think there is also a nice question that applies to most of you. That's coming from Emilia Silvas, who was also in the plenary session on the first day. Like, what are the top design challenges for AI, and why are they challenges in your domains? What would that be? I think, Grigori, you have given us a small hint on that. Can you take it a bit further as the first one?
Hi, I did not quite get the whole question.
What are the top design challenges for AI, and why are these challenges really in your domain, in your field of work? And you can take it from a city perspective, of course. What challenges do you see?
I mean, it's quite a complicated question, to be honest. I think the biggest challenge is to standardize all IE-related. To be honest, I would prefer to call it machine learning rather than IE. I think it's the biggest challenge, in my opinion, is the standardization of how machine learning commits any decision-making procedures in whatever it does. And to be honest, I think if something could cut the edge of promoting machine learning into the industry and into mass market, at the end of the day, I think it should be standardization as a whole.
Okay, thank you. And Nandita, how do you see that? What do you see main challenges? Is that also in the field of standardization, or do you have other challenges?
Definitely. Standardization of how we're interpreting the data, but also to add to that input, data collection continues to be a challenge for AI. Data collection is expensive. So, and especially data sets which are very customized to understanding the driver better in driver assistance and driver monitoring space. So there are consortiums, again, going in that same space of pre-learning that industries can do together, such as we have the MIT Advanced Vehicle Technology Consortium that APTIV is a part of, where they share data about human behavior from naturalistic driving studies. And such steps, including standardization, can really help us all make progress instead of just being in the competitive landscape we are.
I agree. I think standardization and the quality of the data are a big challenge. Also, the choosing of the right algorithms for the type of data that you're getting. We do see more and more AI coming to the edge, which means that you need to be very frugal in your computation needs and your memory usage. And there is a lot of data. There is such a big amount of data, and sometimes you have to choose, okay, which is the data that makes sense and that is really going to help me in the decisions. And in some cases, we do see that depending on the algorithm that is chosen, you might change the way you acquire the data in a way that is even more energy efficient. So working together of the hardware and the algorithm and the architecture and come to the best, we are still learning. It's great. There are so many research teams and so many people working on that, but it's not converging yet.
True. And I think, like for other technologies in the past, it does need some time to come to a stage of convergence. We, on one hand, need to be very eager, but we need to be patient as well. I think it's two sides that we.
Yeah.
You talked about data, and of course, talking about AI without talking about data is quite hard. But I've heard people also striving for data lifecycle management. Is that something that you're working with, or that you feel like we need to establish?
We are
Anyone?
For the ultimate autonomous driving or planning or driving monitoring, we are not into that type of application, but we are looking into the data inside our ICs. And for that one, indeed, getting always the latest one is very important.
Okay.
I let the others answer.
Patrick, is that something that you're working with? No, I was still busy with the previous question. So, but you need there's one thing where it is important, and that is monitoring of algorithms while they are being used, right? And that's a topic we tend to forget. And there, indeed, data management is going to be or already is a very important topic. In Volkswagen, try to tackle that by a data ethics board, which we are establishing and trying to solve that from that side. But one of the most important things is observing the algorithms while they are being used, and then indeed looking into how data plays into that, because it does, right?
Yeah. I'm just hoping that one of the other speakers is also going to reflect on this, but it is a challenging one, and I think it's also one of the things that we need to be either both eager and a bit patient on it to find.
Well, from a technical point of view, we're at the beginning of understanding data, right? And quite seriously, I mean, the mathematical models are there, but making that computable, and things like differential privacy, which makes sure that you can use data even if it's GDPR related problems. You can solve that technically, but again, technically we are at the very beginning there. Give us another decade or two.
Okay, well, we'll invite you for the conference that will take place by then, or in between, to see how we are going. But one of the other things that people talk about a lot also when you use AI and train AI is how do you avoid that you have biases within the work of your teams, within the AI that you develop. Any reflections on that? I think Nandita, you do work on that, right?
So I think bias is sometimes gets a very negative connotation, right? We actually all have biases inbuilt us, and therein lies the problem that sometimes it's hard to detect bias. So having steps in our organization, in our teams to accurately or have checks to actually look for bias is actually an activity in itself, where we purposefully ensure our data set is representing, for example, all genders, ages, to say we are not just focused on a particular demographic. And I think bias is something that has to be kept in mind throughout the process. And like Patrick said, even when we're testing our models out in the real world, getting that feedback when the model goes out in the real world, what is the bias? If there's anything we still missed, because if you don't include that check in the steps, when the model is out there in the real world, it's very hard to actually go back, I feel. And we have to kind of start from the beginning.
Yeah.
Excellently said. If I may add more than one sentence. The advantage of machine learning here is that you can make bias visible, right? Which you cannot in human decisions. So I think it's a plus, but you must be aware of it.
True, and I think it is also what you're saying, like if you expect you can run the whole process without having biases, then you are kind of biased yourself, and you need to be really aware of how visible it indeed is. There's a difference between humans and the machine learning, how well you can spot it, but you need to work with it one way or another. But very nicely phrased, Nandita. Thank you for that. There's one question, and I think it's going to be the last question that we can pick up a bit, and only just a bit. That's explainable AI. We briefly touched upon that as well. I think we're all people who kind of know AI and explainable AI, trustworthy AI. So it's still very in the early stages of it. But how do we make it explainable or understandable for people who are really not in our field and will be using it? How do we make that step?
I would like to respond to that, because I think explainable AI is really nice, but it doesn't mean that we have to explain AI to everybody for everything. So I think in the end, actually, so ordinary people who have not a lot of knowledge about AI, hopefully we don't need to explain anything because it feels very natural. So what I foresee is that, for instance, when vehicles will deviate with specific actions from what people expect, maybe then we need to explain why the vehicle did what it did and why it was the safest decision. But it doesn't necessarily mean that we have to explain the AI behind it for every individual user.
Yep, and I'd like to add to that that sometimes explaining too much to the user, right? Like say you're saying I had 60% prediction, and in my 60% estimation, I made this ad decision. I mean, that can actually erode the trust in the user because they don't have the full understanding, and that 60% doesn't sound like a safe number of a decision. And so sometimes actually can backfire as well.
True. Well, thank you for that. I think, as I said in my introduction, 1.5 hours is not enough. And we started with a slight delay due to technical reasons. And well, they won't give us another 10 minutes to go on. So I'll wrap up from here. Thanks a lot. I think we've touched upon a couple of things that I think will be good to dig a bit deeper into those topics. But we touched on the need for contextual AI and for engagement of multiple actors in drafting this overall approach and for setting these technologies in their applications. We've seen several applications, several steps that AI can contribute to in CCAM, and seen also benefits and risks. So I hope we can still have the word clouds of the risks and benefits a bit in our screen, and we can take them with us. So I hope the Slido expert can help us there. So I think it's really good to have that. We have talked about the need to have a better understanding of what actually user acceptance is and how we can deal with it to be able to actually properly address it and take it on. And that should also help us to demystify AI for CCAM, which is going to be very helpful, I think. So I hope the word clouds are going to be visible also a bit more. I think we've talked about safety and conformity, which would be leading to, well, the buzzword maybe of the conference, but said before in other sessions, that trust is a must. And very nice to see that safety and explainability are, well, now also on the risk. So that's, we need another 1.5 hours. I'm sorry, we will extend this session with 1.5 hours to see why safety is on the risk level. This is interesting, and I think food for thought. So thanks to the audience for feeding this interesting stuff to us. I think we pick it up and discuss it a bit further. Thanks also to Nandita, to Patrick, Marike, Clara and Grigori. And of course also a thank you to my right hands, Oyana Otegi, Emilia Silvas and Julie Kastemans, working with me on the background on the Slido and also on the session report. So thanks a lot. Normally we would have a big applause here for our speaker, so I hope everyone's politely doing that in his living room or study room or wherever you may be. And I have one final message, thank you, yeah. And a final message from the organization team is that all participants of the session are kindly asked to leave this streaming session once I finish my sentence and go from this breakout session. Wait about 10 minutes before the closing ceremony officially will start, but you need to leave this session so we can enter the next one. So thanks a lot, and I hope to see you there and see you next time at the next conference. Thanks a lot.